In this video, I'll be showing you three properties of logarithms, and we'll also be using some of the other things we've learned about logarithms. So the first one here is the product rule. It says the log base a of m times n is equal to the log base a of m plus the log base a of n. Now, if you look at this, you might be thinking that maybe this should have been a multiplication symbol. But actually it is a plus. And in fact, I'm going to say it this way in words. What we have here is the log of a product is equal to a sum of logs. Now, the reason why this is true goes back to one of our properties of exponents. It's actually this one right here. Over here, I've actually given you the proof of this rule. And really, the fact that we have a sum of two logs comes down to this property here, where when you have a to the x times a to the y, you add the exponents and you get x plus y. So really, that's the key step in this proof, and that's why we end up with a sum of logs. Okay, so on number 2, we have the quotient rule, and we have the log base a of m divided by n. So in the first one we had a product, here we have a quotient. So the log base a of m divided by n is equal to the log base a of m minus the log base a of n. So I would say this is, well, the log of a quotient is equal to a difference of logs. Excuse me. And this makes sense. If the log of a product is equal to a sum of logs, then the log of a quotient, which is the opposite of multiplying, is going to be the opposite thing. Instead of a sum of logs, it's a difference of logs. And then finally, we have the power rule, which says if you take the log base a of m to some power p, that we can actually move the p out front. It becomes p times the log base a of m. And so these are the three rules that we have, and you're going to need to get to know these by heart. So let's go ahead and see how we use them. In fact, in calculus and other higher level courses, sometimes, well, and particularly in calculus, sometimes it makes sense to put something in either exponential form or logarithmic form, or in these problems that we'll be doing, sometimes one form is easier to work with than another. And actually, when we get to solving equations in the next section, we'll also find that these properties can help us. All right, so let's look at number 1 here. Well, first of all, notice the word expand. It says expand each logarithmic expression, evaluate logarithmic expressions where possible. So when we say expand, basically we want to write each log as the log of a single value. And so you'll see that in each of our answers. So notice in the first problem we have the log of a product, 5 times 125. And so it's just like what we have here in property number 1, the product rule. So I'm going to go ahead and write the property here, or indicate which one it is. It's property 1. And so this would be the log base 5 of 5 plus the log base 5 of 125. Now, both of these logarithms can be evaluated. Remember, a logarithm is an exponent, and this is the exponent you put on a base of 5 to get 5. Well, of course, that would be 1. And then what exponent do you put on a base of 5 to get 125? That would be 3. And so this reduces to 4. Notice on number 2, we also have the log of a product. And so we are going to use property 1, and it'll look like this. The log base 3 of 5 plus the log base 3 of x. Now on number 3, we have the log of a quotient, two numbers divided. So now we're going to be using property 2. This will be the natural log of a minus the natural log of b. On number 4, we also have the log of a quotient. And so it'll be the log base 4 of 16 Yeah, we are using property 2 here. Minus the log base 4 of y. Now again, hopefully you look at this log here and you're thinking, oh shoot, I can actually simplify that. Let's see, what exponent do you put on a 4 to get 16? Well, that would be 2. So this is 2 minus the log base 4 of y. All right, let's move on to number 5. Whoops, I'm getting ahead of myself here. So notice this time we have the log base b of x to the 7th power. So this is one where we're going to need to use the power rule. We have some base to a power. In this case, it's x to a power. And so we can move that power out front. That's what this power rule is telling us. So we're using property 3, and some people like to use a little arrow like this. This becomes 7 times the log base b of x. On number 6, let's see, we have, again, the log of a power, a to the negative 8 power. So let's go ahead and use property 3, and we'll move that negative 8 out front. We get negative 8 times the log base a of a. Now again, I hope you look at this logarithm and you realize this can be simplified. This is the exponent. Remember, a logarithm is an exponent. This is the exponent that you put on a base of a to get a. Well, that's just 1. So this is negative 8 times 1, and we get negative 8. Excuse me. All right, so on number 7, the first thing I'm seeing here is we have the log of the cube root of x, and if you look at our properties up here, I don't see any roots. So we're going to have to do something here. Well, hopefully you recall that like the square root of x is x to the 1/2 power. In this case, we have the cube root of x. This is x to the 1/3 power. And so we can write this as the natural log of x to the 1/3 power. So now we can use property 3, and we'll move that 1/3 out front, and we get 1/3 times the natural log of x. On number 8, let's see, things are getting a little bit more challenging here. Now notice we have a product, x times y cubed, so we're going to need the product rule. But we also have a power. So does it matter which one I use first? I mean, I'm going to need the power rule here too. Well, here's the thing. I can't just move the 3 out front because I don't have a single base to a power. In fact, the 3 only goes with the y, not the x. And so you can't just pretend the x isn't there. But what we can do is use the product rule. Whoops. And so let's go ahead and use the product rule. This becomes a log base b of x plus the log base b of y cubed. So once we've used the product rule, you can see on the second expression here, now we can use the power rule. And so that's property 3, and so we'll end up with log base b of x plus 3 times the log base b of y. All right, let's go ahead and move on. So we've got 5 more problems here where we're going to be expanding these logs. By the way, let me go back. Notice in each of our logs, we're taking the log of a single value, and that's what we're looking for when we expand. Now, sometimes we'll be able to simplify a log into a number, but otherwise we're getting logs like these where we have the log of a single value. All right, let's go ahead and move on to the next slide. Excuse me. So on the first one here, I would encourage you to do this with all the problems. In fact, you might even want to go ahead and try them. But once I've done a problem or two, I would encourage you to try some of them, and you're more likely to benefit from things if you're able to figure it out on your own based on what we've already done. But at the same time, if you're making mistakes, I'm hoping that you'll learn from those mistakes. All right, so let's look at 9. So really, we have a product of a lot of stuff, and we also are going to be using the power rule. But again, I can't move that 2 out front or the 3 because it's just x that's squared and it's just the z that's cubed, and I can't just pretend that other stuff's not there. But I do have a product of 4 things: 5 times x squared times y times z cubed. And so I can actually use the product rule, which is rule 1, but I'm basically using it more than once here. I'm breaking this into 4 products: the natural log of 5 plus the natural log of x squared plus the natural log of y plus the natural log of z cubed. And now you can see those exponents, natural log of x squared, natural log of z cubed. We can use the power rule and we can move those exponents out front. And in fact, that's all we need to do. We're done. All right, so number 10 is similar, except for now we're also using the quotient rule. We'll end up using all 3 properties because notice we have a product, we have a quotient, that's the fraction there, the numerator divided by the denominator, and we also have 2 powers. So again, it's important to understand what you can and can't do here. In fact, does it matter which property I use first? Now, again, I can't use the power rule because this 2 only goes with the x, and I can't pretend the y's not there, and I can't pretend that the denominator is not there. We don't just have a power or a base raised to some power. There's a lot more going on here. So can't use the power rule. Now I can't use the product rule either because I can't just pretend that denominator is not there. So we're going to have to use the quotient rule first. So this becomes the log base b of our numerator, x squared y, minus the log base b of our denominator, z cubed. Now again, be careful, I cannot move this 2 out front yet because I don't have just a single base to a power. There's a product there I need to take care of first, so we're going to use the product rule, property 1. So let's go ahead and break this first log into 2. It'll be log base b of x squared plus the log base b of y, and then minus the log base b. Now I'm going to go ahead and use property 3, the power rule, and pull that 3 out front. And I also need to do it here. So we're going to end up with 2 times the log base b of x plus the log base b of y minus 3 times the log base b of z. All right, number 11 is similar, but it's going to be a little bit more difficult. I would encourage you to definitely give it a try and see what you can come up with. There's one key step that you've got to be careful. All right, so let's go ahead and look at our the solution here. Again, you're going to be using all 3 rules or properties, but the only one that you could use to start would be the quotient rule, because you definitely do have 2 things divided here. The numerator divided by what's in the denominator, even though it's more involved than that. So let's go ahead and write this as, again, we're using property 2. It'll be the log base 2 of 4p squared minus the log base 2 of q to the 3rd power times r to the 4th. Now notice these are products. Again, I can't use the power rule yet because in neither case here do I have just a single base to a power. So we're going to use the product rule next, rule 1, property 1. So this becomes the log base 2 of 4 plus the log base 2 of p squared minus the log base 2 of q to the 3rd power plus the log base 2 of r to the 4th power. Now be careful here. Notice that I simplified this expression, or I should say I rewrote this expression as a sum of 2 logs. But there's a minus out front here, and so this minus here is going to cause both of these terms to change signs. So let me go ahead and erase these, and I'll go ahead and put parentheses in here. You need the parentheses because you're replacing that single log with 2 logs. All right, so let's go ahead and distribute here. And at the same time, we can also use property 3 to take care of these exponents here. So let's go ahead and do that. So now notice log base 2 of 4, we can evaluate that. What exponent do you put on a base of 2 to get 4? That would be 2. On the next one, let's pull that 2 out front. And then on the minus, this part right here, let's pull that 3 out front. It'll be a minus 3 times the log base 2 of q. And again, don't forget to distribute the negative to this term. You'll get a minus 4 log base 2 of r. Again, notice in all our logs, it's the log of a single value. There's no exponents. There's no other, like product or a quotient. And again, so this is what we mean by expand, when we expand logs. All right, look at number 12, and I'd like you to think about what you're going to need to do first. Okay, so if you look at our properties, there are no properties with radicals in them. We really need to get rid of the radical, and that's not a problem. We can write this as the log of x cubed y to the 1/2 power. Remember, square roots can be written using an exponent of 1/2. And so now, notice we have a product. We also can use the power rule. But the problem is both of these are inside parentheses. We really need to take care of that 1/2 first before we do anything. So we're actually going to use property 3 first, which is kind of different. So far we haven't had to use, or if you look at the ones we've already done, most of the time we're using 1 or 2 first, and 3 usually gets used last. It's kind of backwards here. So let's pull the 1/2 out front. And now we do have the log of our product, so let's break that into a sum of logs. So we're going to use property 1. So it's 1/2 times the log of x cubed plus the log of y. Now again, don't forget, we're replacing one log with 2, and we have to distribute that half. And so this becomes 1/2 times the log of x cubed plus 1/2 times the log of y. And then we can use property 3 again, and let's pull this 3 here out front. And we end up with 3 times 1/2 is 3/2. 3/2 log of x plus 1/2 the log of y. Notice this was a common log which has a base of 10, and it's always good to keep track of your base. Make sure you don't lose it. In this case, it was never written. It's understood to be 10. So 13 is like the ultimate test. If you can do that one, you probably have a pretty good understanding of what we did so far when we expand logs. So I would encourage you to try it and then watch the video. All right, so let's go ahead and start the same way as we just did. Let's write this in parentheses to the 1/2 power. And so we'll pull our 1/2 out front using property 3. And now again, our only choice next would be using the quotient rule. Even with the power rule, you can't ignore your denominator here and just pull out a 5. And so the only thing we can do here is use the quotient rule. So this becomes 1/2 times the log base 2 of a to the 5th minus the log base 2 of b cubed c to the 4th. And yes, you do need the parentheses there. Or if you don't use parentheses, there should be a 1/2 here. All right, so I'm going to actually go ahead and distribute next. I get 1/2 times the log base 2 of a to the 5th minus 1/2 times the log base 2 of b cubed c to the 4th. Now notice I have a product here. I'm also going to be able to use the power rule here. Now I'm going to wait till the very last step to do the power rule. So let's go ahead and use property 1. So this becomes 1/2 the log base 2 of a to the 5th minus 1/2, and now let's write this as a sum of logs. The log base 2 of b cubed plus the log base 2 of c to the 4th. And again, you do need the parentheses there since you're rewriting one log as 2. You have to distribute the half there. So we're going to end up with 1/2 the log base 2 of a to the 5th minus 1/2 the log base 2 of b to the 3rd minus 1/2 the log base 2 of c to the 4th. Now some of you may have already, you may have taken a little bit of a shortcut and skipped one or two of these steps, but you just have to be really careful when you do that. I'm going to go ahead and use the, we're going back to the power rule again, because we have all these powers that we can pull out front. So let's do that. So we're going to pull the 5 out front. 5 times 1/2 is 5/2. So 5/2 log base 2 of a. And then we're going to pull the 3 out front, and 3 times 1/2, it'll be minus 3/2 the log base 2 of b. Now in the next one, 4 times 1/2, or 1/2 of 4, is 2. So this will be minus 2 times log base 2 of c. All right, and again, notice each of these is the log of a single value. All right, let's move on. Actually, I think I'm going to stop this video right here, and I'll do a second video, a second part.